This first activity demonstrates how an infected individual can transmit their infection to others, even if they might not know they have an infection. This activity is going to simulate a gathering of 10 people, and each person is represented by a different colored test tube. So we have white, pink, red, orange, yellow, green, blue, purple, brown, and gray. Now you may be wondering why each color has 4 test tubes if they only represent one person. And this is because each person at this gathering is going to directly interact with 3 others. So they have 3 test tubes to spread their germs to other people. However, they're also going to be receiving germs from others, and so they have a 4th test tube to receive those germs. This is obviously different than reality. As you know, each person only has one body, and that body both receives germs from others and transmits germs to others. This is only one of the differences between this demonstration and reality. We'll go over some others once we've finished the experiment, but while I'm conducting it, try to see if you can think of them yourselves. So for this activity, 1 out of 10 of these people are infected. Their test tubes are filled with sodium hydroxide, while all the other people have test tubes filled with distilled water. At the end of the experiment, I'm going to be adding a drop or 2 of phenol red to each test tube. Phenol red will turn pink in the presence of sodium hydroxide, however, it will remain an orangish-red color in the presence of distilled water. Now I want to mention that I know which of these test tube sets contains sodium hydroxide or has the infection. However, I've chosen all the swaps at random, so that should remove any bias from this experiment. So let's go ahead and start swapping germs. Okay, so now that we've conducted all of our swaps, I'm going to add phenol red to each of the test tubes. Okay, so I added the phenol red, mixed each tube around a little, and we can see that we have blue, green, purple, and gray tubes that are all infected. So here's our green with nice pink color. Blue, also very pink. Purple. And gray. And just for comparison, here is a uninfected tube. You can see it's a reddish-orange color. So we know that when this party started, only one person or 2 had an infection. But we want to try to figure out which of the currently 4 infected people started off with an infection. So I know I sped up the actual experiment for you guys, so let's go over what actually happened. So our green tube received germs from the yellow, white, and purple tubes. The blue tube received germs from red, purple, and white tubes. The purple tube received germs from blue, green, and gray tubes. And lastly, the gray tube received germs from red, pink, and purple tubes. So I'm not going to reveal who began with an infection until the end of the video. See if you can figure it out from the information that I've given you. So I mentioned before beginning the experiment that this demonstration is different than reality. So hopefully you've already thought of a couple ways or differences, but I'd like to go over just a few. So to begin with, 10 is a fairly small group for a gathering or a party. So this experiment assumed that each person would only directly interact with 3 others. However, in such a small group, it's likely that that number would be higher, and each person would be directly interacting with more than 3 others. In fact, you might see each person directly interact with all 9 others. What that means is if there's one infected individual and they directly interact with all 9 others, they're spreading their germs to all of those 9 other people, not just 3. However, as you know, just because you're exposed to a germ or a pathogen doesn't mean you get sick. First of all, not all germs cause sickness, and second of all, we have an immune system whose role is to defend the body from pathogens. You've probably all been around someone who's sick at one point or another and not gotten sick yourself. That's because your immune system is doing the job of fighting off these pathogens and destroying them before you get sick. The last thing that I'll mention, although there may be some other differences as well, is this experiment only demonstrates one gathering, and the 3 additional individuals who got sick didn't go on to infect any others. If there was a second gathering, or these group of 10 spent a few days together, you would start to see those 3 infected people continue to spread the illness to others. So make sure to record the data and information on your handout and answer the questions. Once you've finished, you can watch the next activity.